do SREs use pagers as well? Like what is their form of getting paged? How do we go about doing that?
I just got a call.
Oh, you just get a call. Okay.
Yeah, I get the pager duty call, press 4 without even listening, and then fire up the laptop to see what's up.
Yeah, PagerDuty has obviously kind of been the industry dominator for a long time, although Rootly on Call was released earlier in the week, so we'll see.
That's convenient.
That's fantastic. So I've got a question for y'all. What does MTTR mean to y'all?
Mean time to rage.
To resolve, haven't been burned just yet.
In theory, MTTR stands for mean time to recover, which is some way to measure how long it takes you on average to get back to a known working state. Very popular metric with executives, substantially less so with people who actually do the work of the recovery.
That's fantastic, because quite honestly, MTTR has been a term that has been around in different ways, in different forms for many, many years. I mean, back when I was in my SysAdmin days, we didn't call it MTTR. We just called it a trouble ticket, and we just went and resolved it. And then there was some sort of incident response or some sort of root cause analysis that was done after the fact. Anyways, everyone, welcome to this webinar on reliability, remediation, and response. I've got some amazing individuals from our community to come and talk to you all about all these different things around reliability. Let's do some introductions. Now, do you want to go first?
Sure thing. My name is Niall Murphy. I am currently CEO and co-founder of a teeny tiny startup called Stanza in the reliability, traffic management, yada, yada, yada space. Previous to that, I was in Amazon, Google, and Microsoft for something like 18 years, around plus or minus 16 to 18. And if you've come across my name before, it's probably because of one of my books, most particularly the Site Reliability Engineering book.
Fantastic. Ashley, why don't you introduce yourself?
Sure. I have a copy of Niall's book with many, many highlights throughout it, but I myself am not an SRE. I'm still learning a lot of the technical side of incident response, but I have been in the incident response space for probably close to 10 years now. Currently, I work at Rootly. I'm our developer relations advocate, but really what I'm doing is working with our customers and the community, talking about incident response more from an operational and communications perspective. And prior to Rootly, I was the incident communications lead at Shopify. And before that, I was at the Walt Disney Company, again, in a guest communications type role centered around things going wrong.
Awesome. Fantastic introduction, Ashley. Ricard, why don't you introduce yourself?
Yep. I'm Ricard Bejarano. I'm just from Spain, from Barcelona, Spain. I'm also I have a copy of Niall's books on my showcased on my living room. I have a way shorter career than them both. I'm just 4 years in. I'm a career SRE though. I've been SRE since I ever started working out of uni. But yeah, I currently work as a lead site reliability engineer for the infrastructure team at Cisco Thousand Eyes. And yeah, that's about it.
Fantastic. And my name is Marino Wijay. I'm a solutions engineer at Commodore. That's a company that's focused on platform engineering for reliability, for Kubernetes operations and security as well. And I actually just recently started, so it's kind of nice to be able to be amongst reliability folks here. So one of the things that I wanted to really bring up was a story around a time where I actually caused a massive outage. And what's interesting is sometimes some of these outages are not very predictable because you're expecting systems to just work so fluidly without issue. And if you introduce a small little change, it has a profound radiating impact, either negative or positive. So this particular situation, it was actually a planned capacity upgrade for a little data center environment. You could think vSphere with a bunch of storage and a bunch of networking in a co-located environment. Now, I had to go in there and add nodes, add storage, and basically it involves rebalancing some of the software so that it understands that there's just more capacity involved. And it's a very, very simple task to do. But one of the considerations is you just have to be careful, especially when you're doing the physical part of it, because there's two components. You're racking and stacking, and then you're also having to make changes in software. So physical stuff done, I've racked everything, I've cabled it all up, powered on the additional systems, started the integration process to expand capacity of the cluster. And, everything is looking good. And then everything goes quiet. And when things go really quiet, it's kind of eerie. Like you're like, wait, hold on a second. It shouldn't be this quiet. Things should be quiet, but not this quiet. And then my end user, who I was doing this upgrade for, this capacity upgrade for, they're starting to get emails and calls and text messages. Hey, what's going on? The system's down. What's up? Oh, we just made a few changes, and this environment was down for 8 hours. This environment was a massive organization somewhere in Canada. I can't specify too specifically the details of this particular news outlet, but they went down for 8 hours, and it was, in my eyes, a nightmare, because we don't know what's going wrong. We don't know how to resolve it. And we didn't have all the right tooling, because the only thing we had at the time was calling into support so that they can remote into the systems, look at the control planes, look at the logs, and try and decipher what's going on. And at the end of the day, all we really needed to do was just power cycle controllers to solve this problem. Now, to get to that resolution, it takes a lot. And we're at this point, 10 years later, where we shouldn't have to sit there, waste 8 hours of an outage, and then find that resolution. We should be able to do this very quickly. So having said that, what are some of the mitigation tactics? What are some of the tools? What are some of the systems available to us that allow us to avoid these capacity disasters?
Just thinking about the number of times in my career I've got something wrong by an order of magnitude. Put a zero at the wrong end of the thing, and stuff has gone wrong. So a lot obviously depends on the specifics of what you're doing, the kit you're using, so on and so forth. I think there's a huge interplay between, and I don't think we often think about this, but there's a huge connection between capacity planning and traffic management, and understanding precisely what levels of performance curve you have for a given set of hardware /VMs /URL mapping /application, etc. Because often, particularly in the kind of case that you're talking about, where you have some kind of rebalancing after adding additional capacity, often there can be unpleasant surprises when you think, this is particularly true for auto scaling, by the way, when you think, okay, I've just added 10 new nodes or 20% new nodes or whatever, I should have a bit more headroom, and more traffic comes in, and it turns out that actually you have a feed-in point or a fan-in point somewhere behind a single database or a single resource of some kind, and actually you have much less capacity, you have much less additional useful capacity than you thought you had. What you have instead of something that auto scales but doesn't actually solve anything for you. So there's all kinds of kind of bear traps waiting for us when we're doing significant things like that.
So let's look at
also.
Oh, go ahead, Ricard.
Sure. So it's also, I think we can find the answer to that question a little bit on the principles that we've applied at different places throughout the industry when solving other problems. One obvious one here, and of course it doesn't apply as much to the data center world because it's a physical thing, you don't do it often, but releases are a very similar thing. We only, as an industry, only really got good to releases when we started doing them super often, like every 2 hours instead of every 2 weeks, by hypertrophying, like having that muscle be hypertrophied by doing it and exercising it every single day, every single hour, every single minute, perhaps on larger orgs. You get turns out you get super good at it, and you end up developing tools and processes around it that let you recover quickly from those failures. It's funny, I have a similar story about an outage that also lasted about 8 hours. I wasn't in the data center. I was back at home, like turning off ports to figure out what cable was bad and causing a loop. But yeah, it's a very similar one.
I think something that also stands out to me about Marino's story is the observability piece, in that you found out that that was broken because you're getting all these emails and people are telling you something's wrong. So obviously, of course, we want to detect things hopefully before our customers are informing us, because that means if they've already taken the time to write the email and send it along and you've gotten so many, you know, it's been broken for a while.
Yeah.
And there is actually, we talked about mean time to resolution earlier, but there's actually also a mean time to detection metric that can be useful for stuff like that. When you look at, okay, by the time we knew about this, how much time had we lost that this was already happening, and how could we have detected it earlier?
100%.
Yeah, I completely agree. I mean, that can be perceived as a business loss and even a technical loss from different angles. And that's expensive because you are now having to spend the time and cycles to investigate, which actually is its own cost, right? And that could take hours, days, weeks, months before you reach that root cause analysis. So, what about the prevention side? We could be very specific. There's so many different mechanisms out there that allow us to be very preventative, in addition to be able to monitoring, a lot of these circumstances or situations. How does something like traffic shaping help? Let's say we wanted to control the flow of requests, control the flow of our traffic. How would that help?
Yeah, there's loads you can do here. So if you're modeling the situation in this way, you have some capacity, you've added some more capacity, and you are going to take on board additional customers. Actually, you don't launch again, or you don't bring everyone back onto the platform at the same time, because that just creates opportunities for stuff to go awry. You shape traffic, or you accept a limited amount of inbound requests, or a limited amount of network bandwidth, or however you're managing that. But in the request case, you accept a limited amount of requests, or you do client-side load balancing in some cases. There's a bunch of stuff you can do at the application layer as well to kind of queue people and so on. So in general, you can do traffic shaping to leak people onto the platform in a controlled fashion so that you don't explode the new architecture you've put in behind your load balancers or whatever it is. So you can test stuff. It's a very similar principle to canarying in releases as well, actually, which Ricard just talked about very convincingly. I think if you think about traffic shaping as kind of the canarying of releases, except for application level traffic, that's a good way to get a handle on it.
It's all the same principle. It's about opening the tab slowly, not all at the same time, not opening the dam 100% at a time.
Would you say that that's something that requires like a level of capacity planning and anticipation, or is this something that you can use in the event of like that really, spiky, unpredictable load? Does traffic shaping come into play there? This is actually just me being curious. I'm not trying to lead you.
It's all good.
So, I've got a perspective because I come from the service mesh world, which in itself also is an SRE technology because it focuses on latency errors, traffic, and saturation. But there's a feature in service mesh which offers up the canary style deployment where you can slowly phase traffic, or you could create a stepped approach where traffic gets migrated to a newer resource. And you could basically control this through rate limits and whatnot. So there are mechanisms in place, except we're doing this at much more of an application layer, which gives us some more defined attributes. Sometimes we don't want that level of granularity, and we might want to bring this up to something that has a little less of that granularity, less of those attributes, and we're looking at other things. Maybe we're looking at real estate systems. We're looking at other kinds of data, maybe our network egress, for example, that might give us an indication of how much available bandwidth we have. And that traffic shaping might need to come into effect because we don't want to starve critical services.
Yeah, there's also a cost aspect to this, because at the end of the day, doing releases this way, it's also not easy. If you do them at the L7 layer, it's way more expensive than if you just do it at the network level. And even at a very, very small scale, like it might not even be worth it. You might just develop quick tooling to revert quickly and detect even quicker, and then just revert. So it all comes down to your specific use case and what your scale is and what size of problem are you dealing with.
The thing I'd say about service mesh and network bandwidth and application layer and so on just puts me in mind of thinking about the trade-offs involved in all of these things, right? Because I should make it clear I am not allergic to service meshes. Service meshes are a perfectly fine thing that lots of people do, and if they do it in the privacy of their own home, like that's super cool. I'm not gonna. But the difficulty with the service mesh approach is that it's often really, really complicated and fragile, right? So, yeah. Well, I mean, not to talk down any particular approach, but a service mesh approach is often pretty complex, and it works best when you have a lot of people sitting around who are prepared to manage the service mesh and not really do all that much else, probably. So it's, in my kind of direct experience, a little less agile for architectural changes and infrastructure level changes than stuff that's going on at the application layer. Now, of course, we in Stanza looked at that, and with experience of meshes and other things, chose very deliberately to put stuff in at the code level, which just makes it a little easier to get going and to stop doing. Like, that's one of the other things about service meshes that you might find that you want to quit, but actually it's quite difficult to quit. You don't service mesh patches that you're putting on your arm going, I wish I could stop this habit. Anyway.
You know, service mesh, it is a very niche technology, in my opinion. There is a place to be using it, and there are places where you probably shouldn't be using it. But to your point, it is a system that creates trade-offs because you're introducing additional complexity for that customization, but additional overhead, right? So service meshes add more consumption to the mix, to the conversation, because you're consuming more CPU and memory for things like sidecar resources or the additional logic needed to be made around terminating TLS, or even getting to the point where you're having to make routing decisions at layer 7. So this is why other systems exist.
Yeah, it's also super new. Like,
I wouldn't say it's super new because it's been around for, these technologies have been around probably for about 6+ years, but then they've also had other like forms. So if you think about Java and how it was built, right? It had its own proprietary approach to service mesh.
Yeah, no, that's right. I guess I meant it in a way that it's still a changing space. For instance, I really like the work that's being done on that regard on the eBPF space, where most of the problems that you mentioned about having a sidecar and the added overhead are perhaps even gone. So it's
very much like almost negated because a lot of that processing is done in kernel space. So
exactly.
Yeah, I mean, hats off to the Cilium folks. Just, you know, a little round of applause. Anyways, if anyone else has anything to add, Ashley, do you want to add something to that too?
You guys got it.
Because I want to bring up something else, because while we're talking about capacity planning, the other end of this is, you know, we could have all the capacity planning, all the rate limiting or traffic shaping we want in the world, but that doesn't always guarantee a prevention of a disaster, right? How do we ensure a form of disaster avoidance or a form of disaster recovery in a very automated sense, where we almost don't need to make decisions anymore because this should be a natural part of our business? We shouldn't have to sit there and decide, do we want to move to this other location or recover in this cloud location? Now, what do you think about that?
To me, this really comes down to the same principle that I mentioned before, wherein if you get very, very good at recovering quickly, then disasters are going to keep happening. Like, you cannot prevent stuff. Like, stuff happens, people make mistakes, the systems are managed by people, and then there's also technical failures and stuff you cannot control. There's always stuff you cannot control. And so the more you get used to recovering quickly, failing quickly, and detecting it even faster, and then recovering from it very, very quickly, the easier it is to come back from that and then figure out what's up. Doesn't need to be, it's not necessarily, like you mentioned before, an RCA may take a week for you to figure out. You can leave that for Monday morning, but I got page on Saturday, I need to recover it. Like, let's just press a button, fix it, go back to a stable state, and then figure out what happened on next week.
And for folks that are watching in either through YouTube, Twitter, or LinkedIn, please ask your questions. We'd love to hear them. We've got experts here to answer them. So, ask away. Ashley, I think you had a thought that you wanted to share, or what was that now? No, I couldn't. Someone was ready to speak. I couldn't tell. There we go, Niall. All right, it's on you.
We're grand. So it's a hugely complex space with a lot of different kind of warring ideas and themes that I see in the industry right now. Okay, so when we're thinking about responding to incidents, there is, for example, right now a pro-automation and a anti-automation approach. I think there was the latest Void report came out a couple of days ago, which was basically surprising things happen in the context of incidents and automation. You should be aware of that, which is definitely true. There's also a theme, an idea, which we'll call generic mitigation approaches, like things that you could easily do in the context of almost any outage or incident, and it won't make the problem worse, and that has a good chance of making the problem better. I think there's a paper by Jennifer Mace and a bunch of other people about this, and it might be called generic mitigations or it might be called big red button. But anyway, basic idea is there's a big red button on the wall, software-wise, and when anything goes wrong, you go punch the big red button and stuff gets better. What do we specifically mean by stuff gets better? In the case that Jennifer Mason and others are talking about, they're using a kind of an idea called drain, which is basically you are serving your app across a multiplicity of places. This is coming from a Google kind of large infrastructure, etc. point of view, but you are serving your thing from a bunch of places. And when you drain a data center, you remove the traffic from that data center and you move it to the other data center, and stuff keeps going for the customers. And ideally, they never notice. And there's actually a lot of interesting techniques around how you drain and why you drain. And there's a DNS drain and an internal drain and so on and so forth. But the basic idea is there something quick which isn't damaging that you can do? So we have taken some of those ideas, and we're not doing draining for you, but we can do kind of client-side style activities. So for example, if you have a problem on your back end with out of capacity or some kind of reliability problem, we can effectively put service state into a thing which the clients pull for. And if the specific service that the user would be trying to access, if you were going to log in or search or check out or whatever, if that service isn't working, we can automatically essentially disappear that control on the web UI, whatever, for you. So the problem isn't made worse.
That's cool.
There's a lot of other kind of mitigations that are possible but aren't super generic. And I'm thinking about things like, okay, flip over to the read-only replica or something, which only works for some things. But so there's a lot of kind of system-specific things to this, but the more you can do, what's that phrase they use in medicine? First, do no harm, which apparently is terrible bullshit, and doctors don't actually use that as a guideline at all, or so somebody told me. I mean, maybe it's true. But it's kind of a first do no harm style approach.
I think there's also something in the difference between, when you're optimizing for prevention versus optimizing for quick recovery and making those trade-off decisions, where that concept at a high level is actually something that's really helpful for incident response teams outside of the SRE role to have an understanding of. I noticed that is actually like a source of a lot of conflict and confusion for a lot of teams when they first start taking that incident response process that's happening in their SRE org and, bridging it to other parts of the org where maybe you're informing your customer support team or your comms or your account managers, whoever, I find that that's something that people run up against where those teams, to those of us in the space, we all know 100% uptime is a myth and it's not going to happen. But that's actually something that is news to many people outside of the space. So I think that's one thing that SRE teams can actually help people understand, that the goal isn't entirely to prevent every possible outage. And also the fact that it is possible to mitigate an incident without knowing the root cause. I think that's a distinction that is challenging sometimes for communicators. And I feel like that was one of those things for me that once someone took the time to explain that to me very early on and I understood it, it made communicating so much easier because I stopped trying to tell people, we will ensure this never, ever happens again. Because of course, an outage is going to happen again. But what I could say instead is, here's what went wrong and here's how we mitigated it. And here's what we understand about it now and how we're taking that and implementing it into our systems to be more resilient in this specific way. And it just, once people understand that, it helps at like every level of communicating and understanding what's actually happening when a system is broken.
Yeah, that's so right. And going back to what we discussed about MTTR and that being probably one of the metrics that exec level people look at the most, it comes from the order of priorities, right? Some people going into incident management or commanding incidents for the first time may not think that recovery is the number one priority. That's the really only thing that matters because that's the only thing that users see. And maybe the root cause is just at most top 3. It's right below recovery and the ever forgotten communication with customers, which for a non-technical problem, most of us still lack a lot of expertise there and are not good at it. Like we've always seen the outages where the service is down and then you go to the status page and it's all green and you joke around with that. But yeah, that's so true. That's absolutely right.
Yeah. And it's something I've seen people struggle to communicate before. And one of my old coworkers put it really well, and I've totally quoted him on this before, but we had a situation where we had some outage and there was a lot of pressure coming from the account managers who were managing the largest accounts, the biggest customers, who wanted to know the second service was restored, what went wrong. We want the root cause analysis. We want all of this. And they were having a hard time understanding how we could have possibly resolved the incident without knowing that. And Ryan, my old coworker, said, we don't know what broke the pipe. We just turned off the tap. And I always thought that's such a good way of putting it, that you don't have to know how the hole got there. You just shut the tap off and you'll worry about that later.
I have to say, I have a lot of sympathy for both sides of the incident management / executive management barrier, and it's a huge barrier. Like, do not underestimate the size of this barrier. I have a lot of sympathy for both sides because on the one hand, from the MTTR point of view, just to take a random example, we have some pretty good mathematical reasons, as was put in a paper by Stepan Davidovich a while ago, some pretty good maths reasons to believe MTTR is just not the right metric for kind of measuring this stuff. On the other hand, there's no other one right now.
That's the thing.
Possibly ever. Although we are not into our investigations as much as we should be, right? But executives are kind of faced with the challenge of, we've got a ton of incidents and we seem to be trending in the right direction. Okay, cool. And then random stuff happens and we seem to be trending in a bad direction. But the exact same team is in the exact same position doing exactly the same things they were previously with exactly the same kind of investment levels. Like, what does this tell me, the executive, who is accustomed to managing like a multi-million-dollar thing with numbers, but over here is an area of the business where I can't manage it with numbers? How does that make any sense? Yeah. Anyway, it's all a bit strange.
It's all circumstantial. That's why. But some people don't understand. Like it chaos happens. That's the whole point. That's what we prepare for.
The
So
amount
actually-
of variables in MTTR is just, it's mind blowing. But I honestly don't think I've seen the inside workings of incident management at a ton of different orgs, some that are very well known for doing it better than anyone else. And I've seen that, and I still don't think anybody has really mastered measuring the impact of incidents, especially over time. Honestly, I've yet to see anyone who's like, we've figured it out. Like, we all kind of agree, like Niall said, it's probably not MTTR, but we don't really have anything better. Or you can kind of piece a bunch of different metrics together, like that MTTD and other things. But especially that over time with the amount of variables, it does feel like Ricard said, trying to quantify chaos. Like,
Yeah, and if you're looking for a metric, the one you want really is customer satisfaction or dissatisfaction. It's the inverse. But there's no way to measure that, right? Like, you don't know how happy or angry someone who didn't even report it and just went to another task and didn't notify you is. So it's
so many factors going into that, right? Like, I've found I've tried very hard in very many different ways to measure the impact of incidents on customer trust. And my theory, based on what I've seen, is that it is very much more of a death by 1,000 cuts than any, like, I've never really seen a measurable drop in customers based off of a single incident, no matter how bad that incident was. People don't generally rip out software because it's hard and then they have to replace it. Like, we're talking things that are, business critical or whatever to use. I think at some point there must be a tipping point where, of course, if a service proves itself time and again to be very unreliable, they're going to start looking for alternatives. But it's really, really difficult to actually correlate that data.
Yeah.
I want to be very specific about like the way I've perceived something like disaster avoidance and disaster recovery, because I come from the networking world, the networking background, network engineering, and the challenge probably about 5 to 10 years ago, and this was probably because a lot of the static work that was created and maybe even technical debt was the fact that a lot of organizations didn't want IPs to change. And technologies were invented to prevent the changing of IPs. Ricard's like nodding his head. He knows exactly what I'm going or where I'm going with this. So back in my VMware days, there was a technology called NSX, which effectively created a software network overlay on top of any IP fabric. As long as you had IP connectivity, you could extend layer 2. And that use case was so powerful, especially if you didn't want to re-IP a database or you didn't want to re-IP systems that were hard-coded. Obviously, hard-coding things is a bad idea, but that's how we got here, right? And it's interesting to see how we've moved past that. Like, now we don't even care about IP addresses. Heck, if we're talking about Kubernetes for a second, if that pod disappears, no one cares. No one should care. And it's all because of that abstraction. And it's interesting to see how far along we've come. So given the fact that we've come this far, what are some of the ways people are now developing their incident response plans across the different kinds of places where you can store your workloads and run them? And then how are folks deciding on what are the right sets of tools to choose from?
Ricard, I feel like you probably have
There's a lot there. Yeah.
experience there.
There's a lot there, though. But yeah, I mean, it's an ever-changing space. Like, if you look back at the history of how we've been doing these things, we used to care about where the workload ran, as you said, like where physically it ran. So like at the time, the process was surely different than what it is today. With over time started to move on to more immutable stuff where we just recreate the pod on some other node or recreate the node on some other region. And over time, I think the vision long term that I'm betting most on is along the lines of what Niall said on treating your workload as if it ran on the planet and then just draining data centers back and forth whenever you want to remediate an issue. I think that's ultimately the next step. It's just applying the same principles that we've been applying throughout the years, but just one level higher, so that we keep on iterating. And then I guess at some point we can like deploy stuff on Mars and that. But I hope I get to see that.
Don't you worry though, like if we're creating more abstraction on top to simplify our incident response, we're actually now creating even more complexity to find out what the root cause is, or no?
A little bit, like especially on the human level. Like and it's not that I'm worried, because there will always be someone who is the expert that will be able to figure out the root cause at some point. But it is true, we're dumbing down the systems enough that people that have no idea about them can remediate these incidents, and that is good for productivity. But whenever the really big stuff happens and no one knows why, you'll need an expert that solves that problem, that does that troubleshooting. And if you don't have it because you that muscle you didn't exercise is enough, then it's going to be a problem. But yeah, I don't see that happening anytime soon. Like there's a ton of people, bright people on this industry and this space. So yeah.
I would take a slightly contrary view, I have to say, in the sense that, well, coming back to your original point, Marino, about disaster avoidance and how it's related to you install a new kind of system which makes an entire failure class go away. In this case, the hard coding of IPs in return for some big ass system routing stuff underneath in a find the ladies style shell game, where hopefully you do in fact find the endpoint, but maybe sometimes you don't. The difficulty with this approach is that when you trade reliability for complexity.
Mm-hmm.
In fact, you have not traded reliability for complexity. You have traded, shall we say, one different kind of unreliability for another kind of unreliability. And you could argue, I'm not sure I would actually argue this, but you could argue that as a whole, let's say hard coding of IPs has gone away throughout the industry. By the way, it hasn't.
Yeah, it's not. Yeah.
But you could say that as a common practice, it's like 5% as popular as it was, or something like that. Okay. In return, we now have 400,000 people employed in figuring out how Kubernetes works. Is that good? Like, is that a good societal trade-off? You could argue, is that a good team level trade-off? You put the money into buying VMware products in order to help you overcome your inability to understand how DNS worked. And now you will put the money into Kubernetes in order to overcome your inability to understand how IP switching happens. Like, I don't know. I think you chase around the complexity, and the complexity has to live in your system or company somewhere, and it's a question of who you can persuade to pay for it, really. And I mean, I don't just mean in financial terms, but kind of organizationally and everything. Also, and I do think it's important to mention this, the fact that there may or may not be smart people working in your particular team or industry or whatever, it doesn't necessarily guarantee that any individual problem is going to be resolved within a useful time scale or resolvable at all. One of the weird things about the kind of complexity we tend to get into in this industry, by the way, is we often incrementally build, and we have some kind of Rube Goldberg machine. And so when it disappears or goes wrong or whatever, we know approximately how to restore to the last known good state. But I've been in several incidents where the last known good state is not, in fact, a good state. Actually, it's a broken state, just like all of the other states. But it so happens that the inputs have triggered some problem in it. And actually, you have a very long-running code bug or whatever, which has been in there for the past year or whatever. And it's a complex dance between the environment or the data input and what the system is doing. So anyway, not to be pessimistic here or anything like that, but it turns out to be more complicated than that.
And that's just it, right? Like, you're adding more complexity for the sake of additional reliability at times. Now, that may not always be the case, right? There might be better approaches where you're trading off, handing off that control. Even though there's complexity, there's still control, but you're not owning that control anymore. You're handing off and de-risking. Also, de-risking is the key word here. De-risking yourself from having to manage any SaaS system. I just want to run my application. You can go be responsible for the infrastructure, the upkeep of everything else. as long as my app still runs and I meet my 6 nines, I'm good to
That's
go.
all I care about. Yeah.
Right. And that can be expensive too in its own way, right? I mean, this is why SaaS can be very expensive. But at the same time, if you were to engineer the same kind of solution, it would take you years, right? Because you have to do the trial and error part of it. And then you also have to go through the iterations of working with a variety of vendors. You're not going to go to one single vendor to build that platform that gives you those 6 nines. So a lot of different ways to look at it. I mean, complexity versus cost versus the reliability that you're after. So let me ask you all another question, right? We've talked about systems and the way they could fail and how we could recover from them. What about the people? Who are the people that are actually involved? And sorry for that, something just fell out of my pocket. Who are the people that are involved, and who are the key stakeholders when it comes to incident response?
I think your most important stakeholder to remember is your users, your customers. It's kind of surprising how often they get forgotten. So of course them, and then by proxy, your customer support team. And depending on the nature of the incident, it can be all sorts of things. I mean, I think the most contentious stakeholder is often the executive stakeholder, especially the non-technical executive, kind of like every SRE's worst nightmare is the the CMO or whoever it is who drops into the incident channel with very little understanding of what's going on and a high degree of urgency, because all they really feel is, of course, the pain of the situation. And then depending on the nature, you might even have, your PR team, your legal team, those folks too.
And the engineers.
Other people you've worked with that I'm forgetting.
And the engineers themselves sweating their way through the...
Yes.
Yeah.
So what about an ownership model, right? Like, who owns the comms here? When something goes down, well, there's someone that's got to fix everything. There's someone that has to report on how this is all getting fixed. And there's someone that has to maintain the communication, because you have to manage communication across different stakeholders here, the business side, the end users, the engineers. I mean, we can't have a whole bunch of folks communicating across each other, because that could be chaotic in itself. So what's the best approach, and who's that right person to handle that?
I'm a pretty firm believer that the burden of communication outside of between engineers shouldn't fall to your incident commander or your SRE. I think there's parts of that you can automate and template, like status pages, which if you've got a whole set of templates and you can really quickly do that, that's one thing. But when it comes to more in-depth communication with other parts of the org, I always recommend having that as a standalone stakeholder, whether you have an internal team that's dedicated to incident comms. If you have maybe a more mature program, like we, of course, had that at Shopify. That's the team that I was a part of. I know Google Cloud has the same thing. They have a dedicated customer communication team that will produce those comms. If you're at a much smaller stage, maybe that's a shared responsibility of your PR, your product marketers. I've seen it approached a lot of different ways. And I think generally people have to look at their org and just ask who's best equipped to do this and who can we give the resources to be successful communicating these incidents. Sometimes there is a learning curve, especially if your product has a more technical audience who's going to have an appetite for that technical depth. It's like a good example with Google Cloud. They're going to be a really in-depth incident communication. If you have more of like a B2C type product, your customers probably don't care about the technical details of an incident. So you might approach that totally differently.
But yeah, and also it's very important to lift the burden of that off the incident commander and the response team. You really just want them to focus on coordinating themselves into solving the incident, and that's it. That's the top one priority for them. You can then lift that burden from them and just manage the expectations of the customers and the executives and the business.
I love that. Okay, we're getting close to the end here, so I think it's a good amount of it's a good opportunity for us to start digging into what you all actually do. Like, what are some of the ways your solutions solve some of these problems? Now, why don't we start with you? What is Stanza up to? What are they up to, and how are they solving some of these reliability challenges?
Yep. So we're basically trying to put the wisdom of SRE into software, so you don't have to either hire more or hire when you shouldn't, or wrestle with reliability problems that could be wrestle manually with reliability problems that could otherwise be addressed by software. And so our first thing is a product in the traffic management and rate limiting and resource protection space, where you basically, it's a combination SaaS service and SDK, and you sprinkle the SDK across the code base that you want to protect. I mean, in a very generic way. And every place where you instrument or where you decorate with our code, you get to instrument a call chain in that code path, and you get to rate limit, you get to circuit break, you get free kind of 4 golden signals style SRE observability via open telemetry from where you instrument, and you get to prioritize code paths over each other. So one of the things we do is we can say, okay, if you have an e-commerce site and you have like a login feature and a search feature and a checkout feature, we can, if there's a problem on the back end, fade out the login so that you don't have more people coming in to make a problem worse, like a kind of a Taylor Swift style success disaster where you've loads of people showing up trying to do something, but the checkout call chain can still keep working perfectly fine. And there's a whole bunch of other kind of client side and server side stuff that we do as well. But that's the core thing right now. The thing we just released the other week.
Oh, I think we lost your audio.
You're on mute.
There we go. I've got a double mute going on here, so occasionally that might happen. But I was just going to say, I think you just GA'd the self-service platform. Is that correct?
We have indeed, yes.
Awesome.
So head over to stanza.systems and you can check it out. There's a bunch of developer documentation, other stuff, and you can always reach me or others. And we've got some videos as well. So
fantastic. Ashley, what do we got going on at Rootly?
We got a lot going on at Rootly. So for those of you who don't know, Rootly is an end-to-end incident management platform. So, instead of having to spin up all of your documentation, all of your things when you start an incident, you can use the / command in Slack or click a button in the web platform, and all your integrations that you like to use, your Jira ticket, your Zoom room, all that stuff is instantly created. And then we automate a lot of different elements of the incident response process, mainly centered around removing that kind of manual work and toil and inconsistency. And it's a really good platform no matter what stage you're at. If you're just getting started in building an incident response program, it starts you off with best practices, this kind of default framework that you can use, and then you can customize as much as you want. Whereas if you're a more mature organization, you can, make sure you have that consistency no matter who's on call. You can automate processes. You can pull a Datadog dashboard with the Slack command really quickly and just respond to incidents much, much more quickly. And then we've got lots of good stuff happening with AI and our new on-call alerting feature. If you want to learn more about Rootly, we are always happy to give you a live demo. We can kind of tailor it to how things are set up for you. And you can find us at rootly.com, which is ROOTLY.com.
Awesome. Ricard, what's
Right,
going
that's
on?
a bunch. Yeah, I can confirm everything Ashley said. We're happy Rootly customers, so it's great. It's a great platform. Yeah, Thousand Eyes, it's been around for a while. We do monitoring, so it's a funny coincidence. Niall's product happens in or around the incident, like throughout the incident, and to prevent it and mitigate it. Ashley's Rootly is about responding to that incident. We're about detecting the incident and letting you know that something's up. So Thousand Eyes monitors the internet. It monitors your private internet if you have it, your network, everything from your endpoints up until your devices, your routes, your everything. Basically, it maps out your entire network, and it lets you know whenever there's trouble in there and precisely where, so that you can go ahead and fix it. We're also expanding into a number of other monitoring spaces, such as your cloud flow logs and a bunch of other stuff. But yeah, I'm a horrible salesperson, so I'll just say that it's a great product. We use it internally. I was a customer before joining Thousand Eyes, and I actually joined because I liked the product. So yeah, check it out. It's thousandeyes.com.
Fantastic. And y'all can obviously find me and check out Commodore.com if you want to see what's going on the Kubernetes reliability space. But I also want to bring y'all's attention to SRECon because that is happening very, very soon. Does anyone want to talk a little bit about SRECon?
Yes, so I have been going to and involved with SRECon for jeepers 9 years now, between one thing and another. That is a frightening number. So Stanza is going to be at SRECon. I will be keynoting. So hopefully I will manage to wake up on time, having flown across the Atlantic the previous day or two. So anyway, I'm the opening keynote. We have a booth. Ashley, I think you folks are there as well.
Yeah, we will have a Rootly booth at SRECon and also at KubeCon if anyone's headed there. So definitely come by and meet the team. I myself sadly will not be at SRECon. I'll be in Europe at KubeCon, but I know Dan, our amazing director of engineering, is going, and he's super excited to meet some customers and some folks out there, and some other members of the Rootly team will be there too. Look for the booth. It's booth 416, but you'll see it because there's a very large AI picture of my dog on it. So look out for a weird hug AI generated image, and that's how you'll know you're in the right place.
Is that the official mascot?
JJ, our CEO, and I are in a never-ending battle over whose dog is the official Rootly mascot. So I'm going to tell him that you voted for mine. I'm going to take that.
Sounds good.
Also, Ricard, you're speaking at SRECon too. Yeah, I don't want to.
That's right. That's right. I'm speaking on Wednesday, the last day, about a bunch of the topics that we just covered today, especially about automating disaster recovery and a bunch of the other related topics that we covered today. So yeah, I don't recall what time was it, so just go and check it out at the program. But yeah, if you have any questions to me or want to meet, just come find me in the corridors.
That's fantastic. And for the folks listening in, if you've got any questions, you've got a few more minutes. Now's your chance. Now's your chance to come and ask anything about reliability or how to fix that issue that you're still struggling with for the last several days, maybe, who knows. But I will say I will be at KubeCon, surprisingly. I didn't anticipate that I would be, but I am. I will be there from the Tuesday evening until Saturday. So hit me up. Let's chat. If you want to chat about reliability, I will find Ashley and we will chat about it together with y'all. So hope to see you all there. Final words. Niall, what are some final thoughts that you want to share with the audience?
I suppose I'd say two things: that reliability is often a question of figuring out what you can successfully ignore, or there's trade-offs in every possibility space. And I think one of the things that afflicts the relationship between operations, development, reliability, et cetera, is that people are often in pretty fixed positions about those trade-offs. And actually, it's a lot more, possibility space is a lot more open than that. And bear in mind the particular connection between incidents and traffic and overload and protecting resources and so on. Turns out to be an interesting vector.
Nice. Before I pass it on to Ashley, I've got a question from the audience. What are some automations that can be set in place to quickly resolve common incidents? We can be high level, we can be as granular as we want. Whoever wants to take this one, go for it.
Yeah, I think we covered some of them. Niall made a great list of examples of what you can do about it. And you can think about rolling back, you can think about doing your releases in a stage fashion and then closing the tab back down. You can do traffic management, as we said, to redirect the traffic back to the stable copy of your service. But yeah, that would be the gist of it. The sky's the limit here. This is it's a space that's continuously changing as we change the infrastructure underneath. So it really depends on your specific use case and what your requirements are, and also, as I mentioned, how much, not money, but resources you got to put into it. Of course, all these complex mechanisms to make everything more reliable also make everything, add friction to everything. So you need to also, as Niall said, you need to consider that trade-off before adding any one of those.
Yeah, I
Love
think
that.
something I would encourage people to do is because you can automate almost any aspect of incident response to some degree. If you look back at what slows your team down the most, because I find it's pretty different everywhere. And it depends a lot on the scale of your program and your organization as a whole. So take a look through those retros. And if you're not already doing this when you're retroing incidents, don't just retro necessarily like the technical details of what broke, but also how people communicated, what tool didn't work the way that you thought it might work, or why did it take so long to get a customer email out when we thought it would be quick? All of those things. Look for opportunities to streamline or automate that too. Obviously, like Rootly does a lot of that, but there's plenty of tools, and Niall and Ricard's companies do great automation work too. So
Awesome. Why don't you finish off with some of those final thoughts as well? Or were those your final thoughts?
Oh, final thoughts? Sure. I would say I really liked Niall's. I think you were going in a similar direction to what I was, which is just like getting curious about all the different parts of incident response and the different roles that go into it. And if you're here and you are an SRE, share your knowledge with people in the org. It's really important to help people understand outages, and that's a good way to get more resources for your team. If you're not an SRE, go talk to an SRE, ask them some questions about how systems fail. It's really, really interesting.
The answer is all the time.
In many, many ways, all the time.
I love that Michael K just entered the chat and said, "What about recovery? All of the R's." So I think he's just referring to the fact that because he's a data specialist, especially on the data recovery side, it's something we should emphasize as well. But yes, I agree. I mean, having lived the storage realms and data realms as well, data recovery is important because not only do you have to test out your backups and make sure that things are working functionally, but all your information lives in that data. I mean, if it's unavailable, if you can't read from it, if you can't make decisions, if you can't process data that doesn't exist, well, your systems can't function anymore. So it is worth even testing out whether that data is readable or usable. And I think that's where Mike's going with that. And he has also brought up another point about backup and SRE responsibility. That's actually an interesting question, because does backup fall within the purview of SRE now? Or is that something of an artifact of automation? Because now we look at using things like buckets and like other storage endpoints to be able to store our data. And we expect those systems to have their own inherent like backup and recovery mechanisms. Thoughts, comments?
Are people telling you you should do backup? Well, then it's probably an SRE responsibility. I think it would be hard to imagine kind of a platonic solid SRE team where backup was entirely separate, because if you are charged with the ongoing successful operation of the system and it destroys itself and erases its production data, and you're like, okay, I mean, I guess we're done here, I'll go get another job, and the backup is being taken care of by another team, and they're like, oh, sorry, we didn't know about this or whatever. Like, it seems odd that those responsibilities would be entirely separate. But I guess there might be, okay, this is owned by the data team and they don't care about anything except this data or whatever.
Yeah, it also depends on your org structure, right? I tend to fall like in love more with the structure where SREs are more enablers of reliable operations and not necessarily responsible for the services themselves. So in that case, it would be the application owners or whoever, the group of owners of that data, basically.
And with that, you should finish off with your final
thoughts. Yeah. Now that Ashley brought up the retros, I've been thinking while prepping the talk, because I've been doing that all day today. But basically, one main point that I want to make that I think is super important is that reliability cannot be an afterthought. It really needs to be baked in at the very, very beginning, since the idea is born for a given product or service. Otherwise, you spend a decade patching on top of patches to make the system reliable, epoxying everything together so that it doesn't fall apart. So yeah, let's do more reliability work, especially during the design phase. And also, another thing that I've been doing recently is during retros, maybe not ask the wider audience, because that is another hour of debate, but ask myself what we could have done differently a decade ago so that this incident wouldn't have happened. Not necessarily the stuff that we're fixated on the recent changes that caused the incident directly, but the architecture choices from a decade ago that led to those changes happening and therefore causing the incident. I think there's a lot to learn there, especially as we architect newer services in the future, so that we don't make the same mistakes over and over, and we progress as an industry.
Fantastic. I love those final thoughts there, everyone. My final thoughts to everyone, anyone watching or listening on later on, Google created a book, an SRE handbook that set up a lot of definitions for us. I still refer to it every once in a while, but we've actually evolved from that. It was a good starting point. And in fact, it was built off of practices from many, many, many years ago. I recommend folks look at that today and then look at what we are doing today as SREs, as platform engineers, as even sysadmins. There's a lot of similarities. Automation is very fluid throughout everything that we're doing today. But what's really key is observability systems. That's where the magic lives. So take a look, go explore what SREs are doing today. Heck, even go take a look at various job descriptions to understand the tools that they play with. And it'll give you a glimpse of what's actually going on in this space, in addition to what we've just shared with you. Now, I want to thank everyone for coming by today, wherever you are, whether you're sitting on a beach or if you're on a boat or if you're in a plane or sitting in your home office. Thank you for joining. I appreciate it. I want to thank Niall, Ashley, and Ricard for coming by and sharing all their wisdom about reliability, remediation, and response. Thank you all today. Have a great evening, afternoon, morning, night, wherever you are. We will talk to you soon. And make sure you follow these lovely folks. They're on Twitter and they're on LinkedIn. Take care, everyone. See ya.
Thank you all.
Bye.